About 30 seconds left to finish that warm-up. Make sure you click hand in. All right. That 3 minutes is up. I'm going to move on to the next slide in Pear Deck. You guys can actually exit out of that Amplify tab because you're going to be able to click on a different page. That will take you straight back to Amplify when we need to come back. So you do not have to keep that Amplify tab open. So go ahead, come back to Pear Deck. So after reviewing, your argument needs what? This is where you're going to select a multiple choice on here. I'll show the responses in a second. All right, so make sure you're back in Pear Deck. After reviewing, my argument needs. What do you think your argument still needs? So our assessment is going to be on, for you guys, it's going to be on Tuesday. So Monday and Tuesday is when we're doing the assessment. So we'll have 2.6 today, we'll have 2.7 on Thursday, and some review on Thursday and Friday. All right, and what our assessment is going to be is it's going to be 2 short open responses. You're not going to have any multiple choice. You're going to have 2 short responses. Okay, I'm going to show the answers. Okay, somebody said a better claim. Well, 2 people said a better claim. Some people are saying more evidence. Improving your reasoning. That's always a good one. You can always do better at explaining your thinking, explaining your evidence. These are up to you. Somebody needs to improve all of the above. That's okay. All right, I'm going to hide the responses, and I'm going to move on to the next slide. Okay, so we are going to go into activity 2. So we're going to analyze experiments about bacteria. We're going to look at this new experiment that they have done. And so we're going to analyze and annotate data on 2 different mice experiments. I want you to pay attention to how the different types of bacteria affected mouse gut health. All right, so you explained that the helpful bacteria transferred into the gut during a fecal transplant use up food and space in the gut, making it harder for the harmful bacteria to survive. So these little green things over here on this picture is our helpful bacteria. And we have said multiple times that the more we have of this green stuff, the harder it is for the harmful bacteria to get in. Now, scientists at the Microbiome Research Institute think that there are other ways that a fecal transplant might help a patient. So we looked at one subclaim on Tuesday, guys. Today we're going to be looking at the 2 other subclaims that were a part of that little graph. I'm not sure if you guys remember, but it was this little picture. So we have this overarching claim. A fecal transplant can work to cure a patient infected with a very harmful bacteria, such as C. difficile, in many different ways. And so we looked at this subclaim over here, saying bacteria from the fecal transplant can fill up the space in the gut, which limits the food and space for invading harmful bacteria. We are not focusing on that today. We are focusing on these 2 that are boxed in with blue. So this first one that's boxed in, it's our subclaim 2. It says bacteria from the fecal transplant can help the patient's body produce immune cells that kill invading bacteria. So this bacteria from the fecal transplant can help the patient's body produce immune cells. And this third subclaim says bacteria from the fecal transplant can help the patient's body produce mucus that protects the gut from invading bacteria. So this one is saying that the fecal transplant helps produce mucus. All right, so we talked a little bit about mice and why scientists use mice in the lab instead of using people, obviously. So mice can help scientists get evidence about the microbiome. So we're going to look at 2 more mouse experiments. All right, so scientists bred mice with the gut microbiomes full of only one type of bacteria. This is a good type of bacteria. All right, this bacteria is good. This B. fragilis. All right. So in experiment 2, they use mice with only B. fragilis bacteria in their gut microbiomes. Okay, so this is what I would consider a control, right? This mouse has nothing in their gut, right? No bacteria, no good bacteria, no bad bacteria. Then they tested all of the mice to see how healthy they were, right? The third experiment. So we've got the one with B. fragilis, we've got the mouse with no bacteria in their gut, and now we've got a mouse with L. reuteri. Okay, this is also a good bacteria. Neither of these bacteria are bad. Okay, so in both experiments, the scientists tested the levels of immune cells in each mouse's gut. They also tested the level of mucus that lines the gut in order to see how healthy each mouse's gut microbiome was after the experiment. Right? These are highlighted. So it says immune cells, they tested immune cells. They also tested mucus. The reason that they're highlighted, if we look back at our subclaims, what's our subclaim 2 say? Fecal transplant can help the patient's body produce immune cells. The third one says fecal transplant can help the patient's body produce mucus that protects the gut. All right, so that is why we are looking at these few experiments. They're testing the levels of immune cells. They're also testing the level of mucus that lines the gut. All right, so here's the thing. We've got 2 different experiments. One is going to be looking at the B. fragilis bacteria. The other is going to be looking at the L. reuteri bacteria. All right, so you will not be doing both of them. You're only going to be looking at one of the experiments. All right, so experiment 2, the B. fragilis, the one that's up here on the top. Last names A through M are going to look at experiment 2. Experiment 3, the L. reuteri, last names N through Z are going to be looking at that. All right, so remember it, write it down, keep it in your head because I'm going to take it to the next slide so that you can start on those annotations. Okay, I need you to make at least 2 annotations. 2 annotations. Okay, once you get done with those 2 annotations, you can take a look at the other experiment. You do not have to do annotations on the other experiment. I just want you to take a look if you have time and you get done. All right, so it'll be on the next few pages, just a second. So I'm going to kind of go over what you're going to be looking at. All right, this is the B. fragilis bacteria. This first chart, we've seen this multiple times. It's a normal mouse gut microbiome. Test results are below. This is the control that I've talked about, the one in the middle, a mouse with no bacteria in the gut, no good bacteria, no bad bacteria. The test results are below. This last one is the mouse with B. fragilis in the gut. Okay, it is a good bacteria. We can see down here the gut bacteria key. We know which ones are good bacteria. We know which ones are bad, right? The orange and the red, the C. difficile and the C. jejuni, are the bad bacteria. The only difference with experiment 3, it almost looks like I didn't go to the next slide, but the only difference up here with experiment 3 is that this mouse was injected with the L. reuteri in the gut. So this mouse only had L. reuteri. Experiment 2 had B. fragilis. Okay, so here's where you can click on to go straight to these two experiments. I also have a picture up here. Experiment 2 is last names A through M. Experiment 3 is last names N through Z. All right, I'm going to give you guys 4 minutes. I need you to make at least 2 annotations on the experiment you are supposed to look at. All right, 2 annotations. I'm going to start this timer. You've got about a minute and a half. Make sure when you get done, I put it in the chat to look at the experiment that you did not annotate, because we're going to compare those. We're going to see some comparisons once this timer's up. You got about 45 seconds. Thirty seconds. If you want to, I have pressed the next button on the Pear Deck. You can go ahead and answer that question. You're going to have to type something out. For those of you that haven't finished, you've got just a few more seconds left. So if you want to get back onto Pear Deck, go ahead and answer that question. We're going to look at and compare the 2 experiments. Okay, so this question says, how did the B. fragilis and the L. reuteri bacteria affect mouse gut health? Okay, so how did the B. fragilis and L. reuteri bacteria affect mouse gut health? So this is going to help us look at some of the differences and some of the similarities between them. So what I want you to really focus on are those test results that you see with the mouse that only has B. fragilis and the mouse that only has the L. reuteri bacteria in it. If your peer deck ever stops working or you need to get back in, I'll make sure to put it in the chat every now and then. So if your peer deck ever stops working, it's in the chat. All right, so I've got some people typing. Okay, the mouse with the L. reuteri has high gut mucus. So this first one right here, I've told you guys that the L. reuteri and the B. fragilis are not bad bacteria. They are both good bacteria. We are looking at the test results that talk about the immune cells and that talk about the mucus in the gut. Okay, the B. fragilis had the gut mucus was low and the L. reuteri, the mucus was high. Okay, when you say it made the immune cells low, which isn't good, which bacteria were you looking at? Okay, so make sure you're talking about the test results. Okay, so experiment 2, which was B. fragilis, it made the mouse have a high immune system but a low gut mucus. And then with experiment 3, the L. reuteri, it made the mouse have a low immune system but a high gut mucus. Right, so the difference there, so with the B. fragilis, with the experiment 2, immune system was high, gut mucus was low. And then experiment 3 with the L. reuteri, it was flip-flopped, right? So the mouse had low immune system but a high gut mucus. All right, so I'm going to go back and we're going to look at these together. All right, so experiment 2, B. fragilis. These two pie charts are both the same in the experiment. All right, so what we want, what is a normal gut microbiome? We want our immune cells and our gut mucus to both be high. We want our immune cells and our gut mucus to be high, right? Because if we don't have any bacteria in the gut, they're both low, right? That's what we don't want. We want our gut microbiome to be filled up with good bacteria like this, right? So over here with the B. fragilis in the gut, the immune cells are high, the gut mucus was low. We want this gut mucus to be high though, right? So take a look. I know this is a little bit blurrier than the last picture, and I'm sorry. But the L. reuteri, both of these are the same, the first and the second pie charts. The third one says immune cells were low, and gut mucus was high, which I said was the exact opposite. So what do you think a healthy gut microbiome should have? What do you think a healthy gut microbiome should have? You can answer that in your head or say it out loud, whichever one. I'm going to go take a look at these responses again real quick. Make sure that you are responding. There are 6 people that have not even typed a single word. So make sure you're responding to that passage. All right. Now, we've got a reading. So there are 2 articles. You're only reading one of them. You're only reading one of the 2 articles about the certain type of bacteria. So if you analyze experiment 2, which is B. fragilis, you are going to read the article about B. fragilis. Okay? You analyze experiment 2, you're going to read the article about B. fragilis. If you analyze experiment 3 about L. reuteri, you're going to read the article about L. reuteri. Somebody yesterday said that these look like cheese puffs. All right, let's remember our active reading guidelines. We're going to think carefully about what we read, pay attention to your own understanding. As you read, annotate the text. You can record thinking, you can highlight, you can underline. You're going to examine all visual representations, so make sure that you're looking at pictures. And then after you read, we're going to talk about the bacteria a little bit. So go ahead, you can click on this. If you analyze B. fragilis, read about B. fragilis. If you analyze the L. reuteri, read about L. reuteri. So you can go ahead and click on this page and go straight into Amplify. If you would like to annotate, you can. It is not a requirement right now. So I'm going to put a timer on for about 3.5 minutes. And you all should start working on that. You've got a little over 2 minutes left. Do you need help with annotations? You do not need to annotate. If you would like to, you can. But all you'll need to do, if you wanted to annotate, you need to drag over whatever that you want to annotate, and there it'll pop up a button that says highlight, and you can highlight whatever you want to highlight. You got about 1.5 minutes left. You got about a little over a minute. "45 seconds. All right, so you should have read about that. I want you to come back to this Pear Deck. Okay, we're going to look at the subclaims, and we're going to relate those subclaims to what we just read and what we just analyzed in the experiment. So we're going to look back at the 2 remaining subclaims about fecal transplant, and based on your reading and your analysis of the data, which claim does your evidence support? So you either had L. reuteri, which is the 3rd experiment, or you had the B. fragilis, which was the 2nd experiment. Okay, so subclaim 2 up there at the top left says bacteria from the fecal transplant can help the patient's body produce immune cells that kill invading bacteria. The subclaim 3 at the bottom says bacteria from the fecal transplant can help the patient's body produce mucus that protects the gut from invading bacteria. All right, which one of those do you think that you can support? Which one of those do you think your evidence supports? So what you can do is you can drag the little icon at the bottom to the subclaim that you think your evidence supports. All right, so that is looking at your test results. I would look at your test results, and then you can reference back to what you just read. All right, these responses will be a little different. Make sure you are dragging the little flag to the subclaim that you think your evidence supports. All right, so bacteria from the fecal transplant can help the patient's body produce immune cells. Which one of those talked about having higher immune cells? All right, for subclaim 3, you're looking at the patient's body produces mucus that protects the gut. Which one of those bacteria had high mucus levels? Think back to which bacteria you looked at. You're going to pick which subclaim you think your evidence goes with. All right, so let's go in the chat. And what I want you to do for subclaim 2, which bacteria did you guys say support, or what piece of evidence supports subclaim 2? Which bacteria was it? Okay, so if we look at subclaim 2, it is saying that the fecal transplant can help the patient's body produce immune cells. Okay, so we need to look at which bacteria had higher immune cells. Okay, so I'm going to go back in the slides real quick. You need to look at which one has higher immune cells. Okay, so if we are looking at this pie chart over here to the right, on our pear deck, the immune cells are high, the gut mucus is low. Subclaim 2, where the B. fragilis bacteria supports subclaim 2. Okay, so with the other, it says the mucus will help fight off the bad bacteria. And so we want our gut mucus to be high in that case. So with the L. reuteri, the gut mucus is high and the immune cells are low. All right, so we can say subclaim 2 goes with the B. fragilis evidence. Subclaim 3 goes with the L. reuteri evidence. Okay, so make sure that you have drug the little flags over to the correct spot. If you need to move them, you can. All right, to have a healthy gut microbiome, you should have what? This is a multiple choice response. Okay, to have a healthy gut microbiome, what should you have in your gut? There's only 3 choices here. I'm going to show some responses. Perfect. Why would you want to have no healthy bacteria? The question literally says to have a healthy gut microbiome. You should have what? If you only have one type of healthy gut bacteria, that could be, if you have B. fragilis, you could have high immune cells but a low gut mucus. And you want to have, like I said, you want to have high immune cells and high gut mucus. All right, so you want to have a variety of different types of healthy bacteria. Now, we're going to do our card sort. So on Amplify, here's what I want you to do first. You're going to go answer these 2 questions on Amplify. All right? You're going to answer these 2 questions on Amplify. So I'm going to go to the next page. It'll take you to those 2 questions. All it's asking is which experiment did you analyze and which subclaim you thought it went with. So we've already done that. So we said B. fragilis goes with subclaim 2. L. reuteri goes with subclaim 3. All right, that's what we thought. So go ahead, answer that. You can click on this page. It'll take you straight there. Okay, take a minute, 30 seconds to go and answer that question. If you are already done with answering this question and you're ready to move on, you can go ahead and go into Canvas. We are going to do a card sort. I'm going to introduce the card sort at least because we've got about 13 minutes left to class and I want to make sure that I get to these other things. All right, so you can go into Canvas and start looking at that card sort. All right, this card sort is titled Lesson 2.6, Activity 4, Card Sort. It is in Canvas. I'm going to share my screen so that you guys know exactly where to go for this. All right, so I'm here on modules. You should see October 6th, 2.6, attendance, the card sort, and then the exit slip. So here is the card sort. Take a second for it to load. It's kind of a big card sort. All right, so I'm going to present this so that you can see the instructions. Hopefully it loads quickly. There are going to be a few things that you're going to need to do outside of class. This is kind of a long lesson, so there will be a few things that you will need to do outside of class. So, instructions on each slide. The evidence to the left, you're going to have different evidence cards. They're not all going to be the same. You're going to have cards, I think it's A through J maybe. And it's going to support one or both of the claims. So your instructions are going to be delete the subclaim that is not supported. So what we did with the subclaim 2 and 3 and what we did with the evidence, so either the B. fragilis or the L. reuteri, we picked which one it went with. So we said that the B. fragilis went with subclaim 2 and then the L. reuteri went with subclaim 3. Right? So you're going to delete the subclaim that's not supported. You're going to leave both if the evidence supports both of them. Then you're going to delete both if the data supports neither claim. All right, so I'm going to escape from this. I'm going to make my screen a little bigger so that you can see. That's not making it bigger. Exactly what we are going to do with this. So I hope you can see my screen. I hope it's big enough. I'm in the on the second page of the card sort. And so this is card sort, no, sorry, this is evidence card A. All right. This says on evidence card A, it says L. reuteri bacteria help us digest food and produce vitamins that aid human health. So L. reuteri bacteria help us digest food and produce vitamins that aid human health. Okay, which subclaim does that support? So when you go into this card sort, okay, you can click on this up here at the top. You're going to be able to go in and it'll make a copy just for you. You're going to be able to go in, go to slide 2, and then you can delete whichever box you want to delete. So if you think it supports subclaim 3, then you can click on subclaim 2's box and press delete, and it will go away. If you think you got it wrong and you want to go back, you can press this undo button over there at the top left. If you think it supports subclaim 2, you can go ahead and delete subclaim 3. All right, you're going to go down all 10 of these, and you can delete or keep whichever subclaim you think goes with that evidence card. So this is a totally different evidence card. It says even though they are usually helpful, B. fragilis bacteria can sometimes cause disease. And so you'll decide which subclaim that represent or that that goes with. Okay. Before I let you go and do that, there is one more thing that we're going to go over. So I'm going to stop sharing my screen and go back to Pear Deck. Okay, so I'm on Pear Deck right now. We're actually going to skip the homework for right now and come back to that on Thursday because we don't have very much time. So we're going to skip the homework. We'll come back to it on Thursday. Okay. The last thing that I need for you to do is to complete and submit the exit slip on Canvas. Okay, so these last two things you're going to do on Canvas. All right, you don't have to worry about getting back into Amplify and doing the homework today. You just need to worry about the card sort and the exit slip. These are some extension links if you get done and want to look up some stuff about microbiomes. This is a human microbiome interactive website. All right, so what I need for you to do, I need you to get on Canvas right now. I'm going to give you guys, we got 5 minutes till the end of class, 6 minutes kind of. And I want you to go ahead and start working on that card sort. All right, so you should be on Canvas. You should be on this October 6th, lesson 2.6, activity 4, card sort. It's a cloud assignment external tool. So you guys will get a copy of this and you can modify it. Okay. Once you get done with the card sort, you can go ahead and do the exit slip for today as well. So you guys got about 5 minutes right now in class to do this card sort and maybe get started on your exit slip. I'm going to stop sharing my screen because I've got a few things to do before next class. But you guys can stay on here and make sure you're working on the card sort and then the exit slip. If you guys have any questions, let me know. Yes, you can. Just make sure that you're working on those two things. I'll see you all on Thursday if you do decide to dip out of here.